Oh, final video. Yes. So, step 15, we finally to visualize and deduce our result. Okay, so this is the graph in the time domain, not t prime domain anymore. And then we have x and we have t prime. We have x and t. Damn. And then we know that position x1, the bow x. Okay, position x1, the x1, x0, and x2 is being redefined over here, x1, x0, and x2. And then we have half cycle from 0 to pi and from pi to 2 pi. So at first we derive this portion over here, which is x0 minus fk, if you remember. X1 minus fk, sorry. So it's this portion over here. Let away, don't care about the cosine. Cosine is just the amplitude of the graph itself. And then we also have our where are we? Our x1 minus 3f over k is over here. And then you may wonder, then where is my minus f over k and my f over k? Good question. You give me a moment. No need to give you a moment. Actually, they cancel out each other because if you add up together, should be the case. Because let's say later maybe I'll continue. So later I'll explain it clearer. So let's just continue first, okay? Just taking the coefficient of the cosine out first, and then maybe I'll just pause the video. How about? Okay, I found a reason behind, okay, why we ignore this dude over here, why he's being sadly ignored, because this thing, okay, these things deal with cosine, so it deals with the graph and amplitude. As you know, this one defines the amplitude, this one defines how the graph would move, and then whatever thing that is outside of this whole piece of thing equation, this one will amplify the amplitude itself. Okay, what I mean amplify the whole graph itself. So what I mean is that, let's say sine x is actually this graph over here. Okay, so sine x plus 0 is also this graph over here, but let's say if you plus 2, you see you actually move the graph upwards by 2, even by 3, by 4, by 5, you are moving it down, you see. So yeah, so actually this f over k over here is just external thing that will not affect our graph. So that's why we didn't include it. Because we are talking about amplitude. Okay, we are talking about amplitude. So therefore we are just dealing with the amplitude itself. Therefore that's it, like, you know. So hence amplitude decay. Okay, amplitude decay is just when the difference between this one. Okay, so the reason behind this is that when you from here to here, this portion and this portion is the same. Just that when it comes back up, it's a little different. Okay, when it comes back up, it's a little different, slightly shorter. So you're trying to know this decay. Okay, so we take this amplitude minus away the decay. Okay, you eventually get this dude over here. Okay, so this dude is equivalent to this portion over here. Okay, so in other words, yeah, okay, maybe I explain it in a wrong manner. Damn. So this portion is not the same as this portion. It's maybe shorter a little bit, or maybe not. Let's say shouldn't be. Yeah, it shouldn't be. So apparently, if you were to have that intuition in mind, maybe you give me a moment. Okay, my apology. Okay, so imagine actually the previous one I say is correct. So from here to back to this portion, the pi. Okay, this portion is the same. Okay, this portion is the same as this portion. Just that when it comes from this portion back up, it cannot back up all the way back here. Okay, you just come back to here. That's why we have a shortage of decay over here. Okay, so imagine you I think you understand what I mean. So imagine if you were to pull this mass over here, and when you release it jump back to this position, and then when you spring back, it spring into this position but not back to the position x1, and then it start to oscillate and then decay back to its original position. So this is what it means, and therefore the this portion minus away, because this one deals with the decay okay, this when this point starts moving up, okay, this portion is the same as this portion. It is not the same as this portion. So apparently I think he drawn the graph wrongly, I think. Yeah, or maybe he didn't draw the graph wrongly. Maybe I understand the graph wrongly. Yeah, anyway. Yeah, whatever. Hold on a while. Okay, let's give you an analogy. So this equation is like a speed of the motion of the graph. So the speed from here to here is in this manner, and the speed from here back to here is slightly slower, I would say. This is why when it takes a slightly longer time, I mean a longer, it has lesser energy to pump from this point to this point. So this equation defines the amplitude, but rather that when it defines the amplitude over here, take away that this portion is equals to this portion. However, this portion is not equals to this portion, because the equation itself, the speed, the amount of energy to pump, to spring back from the from this position, from this position back to here, I mean back up, is like this lower energy. So therefore it takes a slightly lesser energy. That's why this equation defines the amplitude. So it still it defines the whole amplitude, just that this amplitude here should be different from this amplitude over here. So it makes sense. So therefore, this thing minus away our decay. Our decay is actually this one. You'll get this portion over here. Okay. Be it that this equation can also be applied over here. Just that when you apply the amplitude compared to this amplitude over here is different. That's all. There's nothing much to argue for. It's just a description of the amplitude. It didn't define the amplitude. So the amplitude for this at this is the same, but at the other half, this point, this amplitude, this amplitude and this amplitude is totally different, and therefore, we are trying to define an equation that would, see the decay, the speed of the decay, I would say, or whatever. So therefore, this amplitude over here minus decay, you get this portion over here, which is initially the same equation for this, equals to this lah, okay? And therefore, when you rearrange, you get 2f over k, but we are just talking about half of the cycle, because typically, yeah, oh, okay, now I understand. So, in other words, perhaps he's just talking about the, okay, so when you're talking about half a cycle, right, you're talking about this portion. Imagine, maybe I should draw it up. You give me, no need to give you a moment. Give me a moment. Shit. Okay, so imagine this is the point, this is phi, and then you go back up, right? And then this is the you know the axis lah, okay? When t, okay, this is the axis, and then this portion is the amplitude is x1 minus f over k, and then this amplitude over here it's x1 minus 3f over k. That would make a lot of sense, okay? So if you were to superimpose back, okay, so this when you flip it out, this thing is likely to be more having a more decay than this thing over here. So we're just trying to find this, yeah. So this dude is actually this, because it takes the same, it is the same amplitude, okay? This amplitude is the same as this amplitude. So I believe he actually drew in fact he drew the graph wrongly. So it should be x1 minus 3f over k, and then this dude, let's cancel it off. Okay, I may be wrong now, okay, but I kind of sound legit now, I don't know. So apparently you're just taking this portion minus this portion, you'll get the decay. We are just taking like how do I say because you're simply taking the difference between them. Yeah, hold on a while. Okay, after looking for a very long time, okay, I have deduced a certain trend, which is damn. Okay, so apparently, this one deals with the top portion. That means from this point to this point. Okay. However, we also have another decay. I mean, because you're actually doing, you're actually doing in this method. So apparently there is another decay from this point to this point. When you flip it out, okay, so there'll be another decay over here. You see? So if you were to look at the graph properly, from this point to this point there will be a slight difference, and from this point to this point there is also a slight difference over here. So the talking about the decay is actually this decay and this decay over here. Yeah, so apparently maybe I should color it in a more nicer color, so we can, so where's the decay? So we're talking about this decay, and we are also talking about when it deflects this direction, talking about this decay. Yeah, so we are talking about, so apparently the equation itself, he when he has drawn its is correct, just that it's not defined properly. So perhaps I am kind of stupid, so yeah, there's another reason. Anyway, so yeah, so for this case, for this portion over here, the decay is actually this thing, and then for the bottom one, because we have to find one cycle so in fact, yeah, it's not one cycle, half cycle already right? It's, yeah, I don't know lah. It's a little tricky. But anyway, so I hope you understand the system of how it's being set up. And I'll leave you to think about how to, phrase half cycle, or but eventually 2f you'll get 2f over k lah. So 2f over k and then is for half cycle, and then since we are talking about 2 decays, so therefore we are talking about 1 cycle. So 2f over k times 2, so we have the final answer. So I hope it brings around very good idea and perceptions on this system. And next video I'll do a summary, and that's it. 8:38, I start from 6 o'clock, Okay, bye bye.